So here's another application of compound interest formula again, okay? So in other words, I suppose $5,000 was invested in some kind of account that paid quarterly interest, okay? So it's compounded quarterly. After 8 years, the account has accumulated to $8,152.98. The question now is, what was the original interest rate? Okay? So we could use algebra to actually answer this question. So recall that the amount in an account after t years, we'll just call it A, okay, for simplicity here, is equal to some principal amount multiplied by 1 plus r over n to the nt. Okay? In this case, we know what n is, we know what p is, and we know what t is. We also know what a is. So then we can compute r. So before we plug any numbers in, let me just show you that using algebra we can get an actual formula where we can solve this equation for r. Okay? So the first thing we'd do is probably divide both sides by p. You see that? So in other words, the first step is a over p is 1 plus r over n to the nt. And then what we want to do is we want to somehow relinquish this stuff underneath this power here. But remember, one way to do that is to take a root, right? A root is the same thing as a reciprocal of this power, right, in terms of powers. And so then what we do is whatever we do to one side, we must do to the other side. So I raise both sides to the 1 over nt power. So 1 plus r over n to the nt raised to the 1 over nt. And we know that in terms of power rule, that this multiplied by this really gives me 1, right? Whenever I raise something to a power, I multiply the exponents, right? And so in other words, I get a 1 exponent here. So it relinquishes this stuff in here. And I'm left with this. So over here, we have a over p to the 1 over nt power is equal to just 1 plus r over n. And now we can subtract 1 and multiply everything by n, right? So you'll see that if I subtract 1, so I get a over p to the 1 over nt minus 1 is equal to r over n, right? And now I simply have to multiply everything left and right by n, and I'll have r by itself. Okay? And then all I need to do is enter all of the terms that I am given, right? All those terms are here. Okay, so let me rewrite this in terms of just r alone, and we could compute the original interest rate. All right, so I've rewritten r that I found before just using algebra, and now I can put in the values that I know. Again, I'm given n, a, p, and t, so all I've got to do is put those over here to find my r. Okay, so out of the problem, I can see that my principal, or what I started with, was $5,000. I know that 8 years is how long it's been there, so the t is 8. I also know that the interest is compounded quarterly, right? So that means that n is 4. There's 4 compounding periods. Also, the amount accumulated is this. So that's the A, right? The amount accumulated, or how much is in the account after t years. So A is going to be amount, which is 8152.98. And all of these values, if I put those into this particular formula, I'm going to get what my interest rate is. Okay? And when you do that, you compute, and you go ahead and do that, you're going to get, I got something around, right around 6.16%, okay, for this particular problem. So if you enter all of these into this formula, you should get this as your percentage interest rate. But this is how you can compute different values. In other words, you start with some amount of values, and you can find some other values, right? By just using algebra on the formula that we're given for the amount in some kind of account in which interest is compounded so many times per year.